This is a very simple model of DNA, and DNA is a double helix structure which contains two phosphate backbone running antiparallel to each other. Okay, and these two backbones are joined together through the DNA base pairing. So imagine this is the A, this is the T, and a G and C. So they base pair to form a double helical structure. So we can use this as a nanomaterial because the scale really fit perfectly in the range of nano scale material defined from 1 to 100 nanometers. Okay, then you can use this as a building block by designing DNA strands that can hybridize with another piece of DNA. So this will bring multiple DNAs together into a network. So what we want to do is to create branch junction structures that can self-assemble into two-dimensional and eventually three-dimensional structure. So we need to we need to break a nick somewhere and imagine to have another DNA helix come on the sideway and break another nick, so you can bridge these two DNAs together by running a strand from one helix and go to another double helix. So you create a four-way junction, and use this four-way junction as a building block. You can build a variety of different nanostructures, and from that you can build supramolecular structures using DNA. We always dreamed about scaling up the DNA nanotechnology. One way to scale that up is to use a cellular system, because DNA can be, simple DNA can be replicated inside of the cell, right, through DNA polymerases and other molecular machines. Okay, so the idea here is, can we challenge the natural system a little bit, and use that to replicate a complicated DNA nanostructure inside of the cell, and maybe that's a venue to scale up the DNA nanoconstruction. Right? So imagine that you can just ship in a piece of vector containing this complicated secondary structure, and use the cell to keep replicating and produce enough amount of DNA nanostructure for us. This is the first example of using cell system to replicate a single-stranded DNA nanostructure, which contains a very complex secondary structure. And also the key thing here is that we also proved the existence of the DNA nanostructure inside during the replication, during the cell amplification, and we found that this DNA nanostructure does exist. Okay, I think that's the first proof that when DNA nanostructure get replicated, it does exist and can survive the complicated cellular machine system.